Hello everyone, thank you for watching Edupedia World videos. In this video, we'll learn about SAP Memory Management. Okay, so we have different types of memory in SAP. So we'll learn what are the different types of memories we have in SAP. SAP Memory Areas Overview. The SAP Memory Management System assigns memory to a work process which executes an ABAP program. The different memory types are SAP Roll Area, SAP Extended Memory and SAP Private Memory. Okay, so all the processing in SAP is done in a work process in the ABAP system. Okay, so whenever a program or anything has to be executed, a work process executes it. To execute that, it needs some memory. Okay, so the different types of memory which are present in SAP they are known as the role area, the extended memory and the private memory. Now, memory management fundamental. An application runs in an SAP work process where a ABAP program is normally executed. The process requires memory to do this, which is allocated to the process by the memory management system. The sequence in which the work process is assigned the memory type depends on the work process type, either dialog or non-dialog, and the underlying operating system. Okay, so an application runs in SAP in a work process. Okay, so and every process it requires some memory to perform the execution. So here, because we have different memory types in SAP, so the type, the order in which each of these three memories are allocated to a work process, it depends on the work process type, whether it's a non-dialog or a dialog work process, and the underlying operating system also. Okay, so it depends upon the OS platform. Now, user context. Data which is generated by transaction process and that is specifically assigned to an SAP user. That is the variables, internal table and the screen list. New external session is equal to the new user specific area plus session context and user context stored in role memory and SAP extended memory. Now, here we have a terminology known as user context. Okay, so this is nothing but this is the data which is generated by the transaction process and it is specifically assigned to an SAP user. Okay, so this is the data which is generated by a transaction, a process. Okay, a user executes a transaction, it's executed by a process. Okay, so all these three put together, okay, what user, which user is executing, what transaction he is executing. Okay, so in the process, everything, all the information related to this is known as the user context. It is specific to the SAP user ID. Okay, it's like the variables, the internal tables and the screen list. Now, a new external session is nothing but it's a new user specific area plus the session context and user context. So, what is a new external session? It's nothing but it's a new user specific area, okay, plus this user context, the session context and the user context. That is, see, you have logged on to the SAP system, you have opened the screen. Okay, then again you open a different screen, you are navigating from one screen to another. So the external session is nothing but that old previous session. Okay, the context, like what it's contained in the earlier session, the information contained in the earlier section plus then the information which is opened in the new window. Similarly, if you open a third window, then so this user will have the old two windows user context information plus the new one which is open. Okay, so it's like that, and this user context is stored in the role memory and the extended memory. So when we say user context, it is stored in the role memory and the extended memory. Now, sessions are divided into two types. We have an external session and an internal session. External session is the one which is explicitly opened by the user. when the first screen you open, from there if you say /o some transaction, then a new session will be open. So that is the external session. The internal session means it's opened implicitly by the program. Okay, so whenever you do some transaction processing, so internally SAP has to generate some screens and sessions. Okay, so that is known as the internal session, like submit, call transaction, call dialog, call screen, call function in update task, call function in background task, and call function starting new task. So these are all like the different types of sessions, external or internal. Okay, so user context means it's the information pertaining to a specific user, which has all the details like what is the user ID, which transaction he is processing, which transaction report or whatever it is, all the variables, all the internal tables, everything. When you open a screen, internally it has so many screen elements, so it contains all the information about that along with the user ID. Okay, so that is known as the user context. Okay, and that user context is stored in the role memory and the extended memory. Okay, and we have two types of sessions. In general, we have an external session, it's explicitly opened by the user, and the internal session, it's implicitly opened by the program during the processing. Okay, now the process flow. We have the SAP GUI here, that's the presentation server. We have the SAP application server and the database server. Now first a request from message server, it comes to the dispatcher queue of an instance. Okay, then it's assigned to a work process. It sits in the dispatcher queue for some time and it's assigned to a work process. Okay, so these are the different types of memories. We have the role memory, the extended memory, and the buffers. Okay, so now and here we have the database process. We have a database buffer and the database. Okay, so we have the different work process. Each work process communicates with each of this available memory types, like it can be an extended memory or a role memory or the different types of buffers. Okay, and this entire thing is known as the shared memory, and the shared memory is specific to the application server. Okay, every application server in an SAP system, you will have n number of instances, n number of application servers. So each application server has some shared memory. Okay, so that is about this one, the memory which is assigned to a work process. Now the role memory. So first we learn about the role memory. Local SAP role area work process. The initial part of the user context stored. Each SAP work process can only access its own role area. Okay, so this role memory is the area in which the user context is stored. The first time you log into a system, you open a screen and the transaction in it. So your user context is created for the first time. Okay, and every SAP work process also has some internal memory. Okay, here this is the shared memory, the shared role memory. However, every work process also has some internal memory, that's its own role area, it's known as. Okay, so that's the local role area of the work process. So first time when you log in, a user context is created in the work process role area. The first time the user context is created in the work process role area, and every work process has its own role area. Okay, these two things we should be clear about, the local SAP role area of a work process. The next one is the shared SAP role area. This is accessible to all instances work process. Okay, so this one I'm talking about, this role memory. This memory is shared. Every work process can access this memory. We have a buffer to temporarily keep the user context when a user is assigned to a new work process. So here also we have an intermediate buffer to store the user context, the role buffer, that is. When the context of a work process changes, the data is copied from the role area to a common resource known as the role file. To prevent repeated copying, and the role buffer is located in between, which is part of the shared memory. Okay, so when there is a switch between the work process, that is the work process multiplexing. So the new work process which takes up your task has to get your user context from the other work process. So what happens when a work process completes a dialog step of a user? It writes all the contents to the role buffer. Okay, then it goes to a new task. Okay, so then all that contents are copied to the role file. Okay, so we have an intermediate buffer and we have a role file also. So when the new work process picks up your task, it has to get the information from the role buffer or the role file. Okay, here we have that's what, to prevent repeated copying, under role buffer is located in between, which is part of the shared memory. Okay, so on top of the role file we have something known as the role buffer. Now here we have two concepts, roll in and roll out. Roll in means it's copying the user context from the shared role area to the local role area. Roll out means copying the user context from the local role area to the shared role area. Okay, roll in, a work process gets the user context from the shared role area to its own role area. Roll out, the work process moves out the data from its own local role area which is there in the work process to the shared role area. See, in the next here it's shown diagrammatically. So we have a work process 1, 2, 3, etc. Every work process has its own role area, that is the local role area. Now we have the buffer and the file. Okay, this is the buffer is present in the shared memory. So the context which happens, so it writes this information to the buffer and it's stored in the role file. When this work process has to pick up that particular the task, then it accesses this information from the buffer or the file. Okay, so this shows like what are the different types of role areas we have. Now we are talking about so many memory types like role area, extended, private, everything. So we have to set initially, when the configuration of the SAP system is done, we have to set all these parameters to some value, right? So coming to the role area, okay, these are the different parameters we have. ZTTA role first, it's the first amount of role memory in bytes assigned to a dialog work process. Okay, so the local role area, this I'm talking about. So first, for a dialog work process, it's assigned to this value, ZTTA role first. Then ZTTA role area, the size of the total SAP role area in bytes. Okay, so this one, this role area is nothing but the entire role area, the local role area of the work process. Now RDISP role SHM and RDISP role maxFS. This is the size of the role buffer and maximum role file size. Okay, so we have two other parameters. One is the role buffer and the role file. Okay, here this is the role buffer value and the role file. Okay, so from here the roll in and the roll out happens. This is roll out or it could be a roll in. Okay, that's why this is bidirectional. A work process, okay, can get the information user context from the role area, the shared role area, to its own local role area, and the work process can also send the information out from its own local role area to the buffer, to the role buffer. Okay, so we have 4 parameters here: the role first, the role area, and the role SHM is that of the buffer, and the role maxFS is the value of the role file. Okay, so this is about role area. We have 2 types of role area, local and shared. Okay, and the parameters and how the user context is switched. Now the next one is the SAP Extended Memory, the shared memory where all SAP work process can edit and store the user context directly. roll in rather only copies the address or the pointer of where the user context is located on the SAP Extended Memory, which makes roll process much faster. Now, this user context, after using this role area, whether it's the local one and the shared one is nothing but it is kept in the shared area, the user context. However, for executing, that user context has to be brought inside the work process local role area. Now, after that role area is completed, it will need, if it needs some more memory, then it can get from this extended memory or the private memory, that is the operating system page file. So here this extended memory is nothing but, in this picture we have the role memory, we have the extended memory. So here also the work process can store the user context, and it can access it. And in this extended memory, all work process can access this extended memory because it's shared across all the work process in an instance. So when a roll-in happens, what it does means it copies the pointer where the user context is located on the SAP Extended Memory, which makes the roll process much faster. So for a roll-in means the information has to be the work process has to get the information from the extended memory to its own local role area. So here what happens, pointers are used, so it brings that pointer, and that pointer points to the role area and the whatever the user context in the SAP Extended Memory. It's not the role area, it's the user context in the SAP Extended Memory. Now the parameters related to this extended memory are EM initial size MB. This is the size of the SAP Extended Memory allocated when the SAP instance starts up. So the first one is the initial size of the extended memory. The next one is the EM block size KB, the size in kilobytes of the segments that are assigned to the SAP Extended Memory. So it's nothing but this block size. This is the initial size MB, and the next one is the individual block size. Then CTDA role extension, the maximum size of the user context in the SAP Extended Memory. So one user can't use all this memory, right? So we will set a maximum limit of each user context in the extended memory, that is determined by this parameter, CTDA role extension. And ZDDA role extension dia, ZDDA role extension non-dia. We have two other types. This is the maximum quota for a dialog work process, the maximum amount of extended memory a dialog work process can use, and the other one is the maximum amount of memory a non-dialog work process can use. So once the role area is over in the work process, if the work process needs more memory, then it takes from the SAP Extended Memory. This extended memory is common to all the work process. And for this we have all these parameters: the initial size, the block size, the role extension dia, and non-dia. So we are completed with two types of memory, the role and the extended. Now the third type is the SAP Private Memory. If the extended memory is fully occupied, or the limit for which the work process has been exceeded, the work process allocates heap memory. Now the role area of the work process is over, the extended memory is also occupied. If for the processing, if still it requires more memory, then that is fetched from the heap memory of the operating system. This is known as private memory because it is specific to the process, and the user context can no longer be processed by a different work process. Why this is known as private? Private means it's exclusive to that work process only. When a work process is assigned a private memory, so only that work process can access that private memory until it completes its full processing. Okay, so that memory will be withheld by the work process until it's completed. Okay, so that is about this private memory. If too many dialog work processes run in the priv mode in an SAP application server, the performance problems arise. The normal processing of the user inquiries is slowed down by the priv mode work process. Because this is an exclusive memory, it's withheld by the work process until its processing is completed. Okay. So if we have too many dialog work process in priv mode, that is not at all good for the system. Okay. So the performance of the system will slow down eventually, because so many work process, they are simply taking up more of the heap memory of the operating system and they are not releasing it. So for the other process, the memory, see, you have to take memory and release it back again. Then only the other process can use it. If all the work process, they take memory and they don't release it back, then what will happen? New requests can't be attended because they'll not have sufficient memory. Other work process will not have sufficient memory to process the new requests. So then serious system performance problems arise. Okay. So the SAP system offers a mechanism that lets you terminate non-active dialog process in priv mode. This mechanism helps reduce the performance problems. So because this condition may arise sometime, okay, knowingly or unknowingly, so we can set a maximum time. Okay, after this time, the work process in the priv mode is, what will happen means it releases that task. It simply restarts. Okay, say like if it's for 20 minutes, okay, the work process is in priv mode. Okay, still that task is, it's just like some endless loop or something. Okay, it's like keeping on, it's continuously running. So we have to either kill such things manually, such process manually, or we can set a parameter where we can terminate the dialog work process in a priv mode after some time. Okay, now the heap memory parameters. These are the different parameters in the heap memory. Above heap area dia, the quota of the SAP heap memory that a dialog process can be allocated. Heap area non-dia, the quota of the SAP heap memory that a non-dialog work process can be allocated. Okay, so dia is for a dialog work process, non-dia is for a non-dialog work process. In the above heap area total means it determines the upper limit of the heap memory in bytes available to all work process of an SAP application server. Okay, so this is the total heap memory where all the work process can use that memory. So we have a quota for a dialog work process, we have a quota for all the other non-dialog work process like the batch, update, spool, etc. and the total heap area where all the work process in an SAP instance can use the maximum limit. In the heap limit, the work process restart limit of a heap memory. So that's what. When the work process, has used a lot of heap memory, say like it started with 1 MB, 2 MB, 3 MB. So we have set the heap limit as 10 MB. So once that work process used all that 10 MB of heap memory, then it will automatically restart, because see, the SAP will allow until a certain limit where the work process can use the heap memory. Okay, say like if it's continuously using more and more heap memory, then we can set a limit. Okay, so this is the point which we have discussed above. So after this limit, the work process will simply restart. Your session will be automatically closed. Okay, so this is about the private memory. It's nothing but the heap memory, the operating system paging. Okay, where the SAP work process can use, and these are the different parameters related to heap memory. Now, the sequence in which memory is allocated. Okay, So for a dialog work process, the sequence in which a memory is allocated is different, and for a non-dialog work process, it's different. Okay, so this is for a dialog work process. So the first one is the CTTA role first. The initial role area is provided. That's what this CTTA role first is provided. Next, if the initial role area is not sufficient, the SAP Extended Memory is assigned. Then it goes to the SAP. It gets some amount from the Extended Memory. Then, if the Extended Memory is also not sufficient, more memory is given from the role area until it's used up. That is the role area minus role first. This one, this remaining amount. So first it's used, then role area minus role first. That entire one is used. If the user context still requires more memory, the heap memory is assigned. Okay, then it goes to the heap memory. Okay, so for a dialog work process, it's CTTA role first, role extension, then role area minus role first, and because it's a dialog work process, it's the heap area dia. Okay, so that is about the dialog work process. Okay, the sequence in which the memory is assigned to a dialog work process. Now, the sequence in which the memory is assigned to a non-dialog work process. So first one is the role area is used. Memory is taken from the role area, ZTTA role area. So this entire role area is allocated in one shot. Then it goes to the heap memory. If role area is full, heap memory is allocated. Because it's a non-dialog work process, so this value, heap area non-dia. And then it goes to the extended memory, CTTA role extension. If no more heap memory can be allocated, then the SAP extended memory is used. Okay, this is for the other background work process. Okay, because this background update or enqueue or spool, they are designed in such a way that they will not handle interactive requests from the SAP GUI or from the web. So it is not a problem that a background work process runs for say 10 hours also. Okay, because to get the requests, okay, when additional users log on or additional a request sends an additional a user sends an additional request to the SAP system, it has to be picked up by a dialog work process. Okay, so first thing is like if too many dialog work process go use the heap area, okay, so then after they use the maximum limit of heap area, the user session will be terminated. Okay, but for the other non-dialog work process, the heap area is used first and then the extended memory. So for the dialog, it's role first, extended, the other role area and the heap memory. But for a non-dialog work process, it's the role area, the heap area and then the extended memory. Because here too many context switches will not be there. For a background, if you submit a background job, it will run until that background process is completed successfully or failed, whatever it can be. But for a dialog work process, lot of context switching happens. Okay, so that's why heap memory is nothing but it's a private memory. Because of this context switching, okay, you have to pick up a task. Okay, a dialog work process has to pick up a task. It has to complete the dialog step and hand over it to a different dialog work process. If it's using this heap memory, then it doesn't denote like, see, why to go for a heap memory? It's something like private, so that I'm running this task for say 3 hours. I need some private memory that is suitable to the non-dialog work process. But for a dialog work process, heap memory is the last option, because you have to pick up a task, complete some dialog steps and hand it over to the other dialog work process. Okay, there should be a lot of user context switching happening. That's why after the own role area, it goes to the extended memory, and then only the last option is the heap memory. Okay, so this is the order, the sequence of in which the memory is allocated to a dialog and a non-dialog work process. Now, the SAP EG memory, EM global area B. This value specifies in megabytes the maximum size of the part of the extended memory. Okay, this parameter that is reserved for the global data, that is user independent and work process independent data. So this global area is nothing but it's a part of the SAP extended memory only. Okay, so where it is reserved for the global data, that is the user independent and the work process independent data. The amount of data involved is comparatively small, a percentage of the whole extended memory pool, because only administration data belonging to internal communication between SAP kernel components is stored in the global area. Okay, so this area is not specific to a user or a work process. It's completely independent data. It's used for administrative purposes. Okay, like the communication between various work process components or whatever it is. Okay, so the global data. Okay, so this is part of the SAP extended memory only, and this is the parameter EM global area MB. Okay, now when we talk about the SAP paging memory, this enables the row area to be extended at above runtime when a large data set, the internal tables for example, is handled. So that's what. The data types extract and import to memory remain in the SAP paging memory. So if in your ABAP program you use this extract or export, then it uses the SAP paging memory only. And this paging memory parameters are the size of the paging file and the paging buffer. So similarly to the role area, we have a role buffer, a role file. Here also we have a paging file and a paging buffer. And what are the errors related to this SAP paging memory? It's like memory no more paging. This error you will get. Okay, if that work process has used too much of the paging memory and it got terminated abnormally, then it will throw like memory no more paging. Now, these are the different types of buffers which we see in the shared memory. So we have a program buffer, a paging buffer, a role buffer, the SAP cursor cache. Okay, we have discussed in our last videos in this training. Cursor cache, it stores all the parsing information of the SQLs. Okay, then we have this partial buffer, factory calendar, generic buffer, info buffer, and the R3 repository buffers, all these. Okay, so all the buffers are also stored in the shared memory. Now, the configuration and monitoring the SAP memory areas. What are the main factors we have to consider? Okay, while configuring all these memory related parameters. The first one is the physical main memory. It's the RAM of your host. The next one is the swap space or the paging file of the operating system. Then when we have like this private memory, so you have to see like what is the paging file of your operating system and the other operating system restrictions. Okay, so we have the main memory. We have to consider the main memory, the paging file, and the other operating system related restrictions. Now, the following tools are suitable for monitoring. To monitor this memory related things, the first transaction is STO2. That's the tune summary. Okay, so many times till now we have learned about STO2. All this buffer related information, everything, the memory parameters, everything you can see from STO2. The next one, the current status and the memory resource usage for a specific SAP application server are displayed here. Now, the transaction STO6 is used for monitoring the available swap space in the host system. So, operating system related memory you can see from STO6. Then we have the other one, the CCMS alert monitor from RZ20. Then overview of memory allocation to users, you can see from transaction SN04. The overview of memory allocation to work process, you can see from transaction SN50 and just 66. Okay, and the swap space requirements, if the swap space on a computer is used up, serious system problems occur as a result. Okay, so in general, STO2 shows the memory related to SAP. STO6 shows the memory related things from an operating system point of view. Then this RZ20, the central alert monitor, where you can monitor all the memory configuration and everything. Then the memory allocation to users on each instance, you can see from SN04. And the memory allocation to work process, you can see from SN50 from each instance, or SN66 from the global work process overview. And the other thing is, if the swap space, the operating system swap space runs out, then serious performance problems arise. So even some monitoring has to be done from the OS level also related to this SAP Memory Management. Now, Zero Administration Memory Management on Windows. The basic for this is the Dynamic Extended Memory. So we have a concept known as Zero Administration Memory Management on Windows Server. So here this is nothing but we have a Dynamic Extended Memory. Initially, the extended memory is set to the size of the profile parameter PHYS mem size. If the user requires more memory, extended memory extends itself in steps from this PM by 2 up to the set limits in the profile parameter EM max size MD, or until the address space in the Windows page file is used up. The profile parameter, this PHYS mem size, determines how much of the total main memory is used by the SAP system. The default value for PHYS mem size is the size of the main memory. The basis for Zero Administration Memory Management is a sufficiently large Windows page file. Okay, so here first the concept is nothing but we have a dynamic extended memory. Say like first if it's 50, then it extends by 2, then it extends by 25, next time it extends by 12, like that. Okay, so first this PHYS mem size is set to the size of the RAM which is available. Okay, and it can extend itself. It uses the operating system page file to get more memory. Okay, so it can like keep on extending itself until the page file is used up, or we can set a profile parameter. Okay, EM max size MB. So we can stop it from extending too much by using the profile parameter. Okay, so this is the concept of Zero Administration Memory Management on Windows. Now, the assistance with troubleshooting. Why? You know what type of errors we face when we run out of memory. The transactions, they run very slow. Then the session terminations happen. User is simply logged off, or the ABAP program terminates. Okay, so when we are running out of memory in an SAP system, okay, there could be like any problem. The page file operating system swap space is less, or the paging file is less, or the extended memory, some problem. Okay, the buffers are full, whatever it is, then your transactions start running slowly. The sessions terminate abnormally, simply users are thrown out of the system. Your ABAP program terminates with a dump which is recorded. Now, what are the four? We have some main factors which cause memory problems. First one is the program errors. The first important thing is the coding errors, especially all these endless loops and everything. Next one, the SAP profile parameters are set incorrectly. So initially we have done some mistake. Okay, we have not correctly estimated like what is the usage of the system. So we have set the memory parameters very small initially. Okay, because these parameters are set incorrectly, then memory related errors occurred. And the next one is the swap space on the operating system is not large enough. Okay, and the configuration parameters of the operating system are set incorrectly or the OS limits have been reached. So because SAP system also uses the operating system, the swap space, the paging file, okay, even those the operating system memory configuration also has to be done correctly. Okay, so the coding errors because incorrect configuration done at SAP level or operating system level for the memory related parameters, or at the operating system you don't have sufficient space. Okay, so these are the 4 main factors causing memory related problems. So here I have listed the different types of ABAP dumps, like storage parameters wrong set, okay, TSVT, new occurs, no roll memory, etc. All these. Okay, so I have just listed what are the different types of ABAP errors we get related to memory, like system no roll, memory no more paging, all these. Okay, these are the few ones which I have listed here. You can find other related memory dumps also. Okay, so just to brush up what we have learned in this video, SAP Memory Management, we have started with the different memory areas, the role, extended and the private. Then we have learned about the user context. Okay, then we have learned about the role memory. We have 2 types, local role area and the shared role area. Okay, so here it's shown in this diagram how it happens and the parameters related to the role area. Then the SAP Extended Memory and the parameters related to extended memory. Then the private, the heap memory and the parameters, and the sequence in which the memory is allocated to a dialog and non-dialog work process. Then the memory in the extended memory used to store the global data. Okay, so this is the parameter EM global area MB. The next one is the paging memory. Okay, and the parameters. Okay, then what are the different types of buffers which we see in the SAP shared memory? And a very important point is here, optimal buffer sizes are required to avoid excessive swapping or paging. Okay, if the buffer size is very small, then frequently the data has to be swapped from the buffer to the file. Okay, to get new data it has to push out the old data. So too many swaps occur, which is not good. Okay, if the buffers are very large, then it's simply waste of space also. So you have to be very careful in setting up the optimal buffer sizes. Then what are the main things which we have to keep in our mind while configuring the SAP memory? And what are the different transactions or the tools used for memory monitoring? Then we have learned about the zero administration memory management on Windows. Okay, so what are the errors we get if memory issues are there in the system, and the factors which are responsible for memory related problems. And the last one is, it's nothing but it's a small list of ABAP dumps which we get when memory problems occur. Okay, so this is about SAP Memory Management. Thank you.